Okay, so letter C is just about basic exponent notation and understanding. So this is always our base. This is our exponent. Probably what people miss is if it's a quantity like this and it's negative. So if a negative base is raised to an odd power, it's negative. So let's think about that. A negative 2 squared is negative times a negative, which is positive. A negative 2 to the third, negative 2 times negative 2 times negative 2 is negative because the two of the negatives cancel. Odd means there's always going to be one left by the end to make the whole answer negative. I want you to be careful though. Nope, this isn't what I want. Let's look at this one. This negative 2 quantity squared means negative 2 times negative 2, which is 4. This means the opposite of 2 squared. The opposite of 2 times 2. This side is negative 4, which does not equal a positive 4. If the negative is in parentheses, you're taking everything in parentheses and squaring it. This square just applies to the 2, not to the negative. That's really all letter C is about. Then D is about the laws of exponents. If you had me last year, I went over and over and over. But I do like how some of the boys, they summarize this. When you're multiplying bases that are the same, keep the base, add the exponents. Keep the base, add the exponents. When you're dividing bases that are the same, keep the base, subtract the exponent. We say that A cannot be 0 because 0 can't be in the denominator. If you raise one base, a power to a power, multiply the powers. If you're multiplying inside, you can give each one its own exponent. The power of the product is the product of the powers. Same for division. You can separate multiply, you can separate divide. You cannot, notice there's no rules for add and subtract. Products, quotients only. Now, these two I'm going to start. Anything to the 0 power, 1. And a negative exponent means it's a fraction. Let me come over here. A to the negative n, what I'm going to do is I move it to the denominator. In moving it to the bottom, the exponent becomes positive, and I use 1 to hold the spot. Also, if it's negative in the bottom, I can move it to the top, and the exponent becomes positive. So a negative exponent either moves it to the bottom to become positive or moves it to the top to become positive. So let's see some of that in action. I'm multiplying bases that are the same. Keep the base, add the exponent. Multiply bases that are the same. Keep the base, add the exponent. So I like this because they give you both a numerical example and a variable example. When you're multiplying bases, you don't multiply the base itself. Keep the base, add the exponents. And if you really want to, if it's not making sense, this is saying there are 4 7s. Then I'm multiplying another 5. So how many 7s are there altogether? 9. So you're keeping whatever is the same stays the same. All right, so I'm dividing bases that are the same, so I keep the same base, subtract the exponent. I'm dividing bases that are the same. Keep the base, subtract the exponent. Power to a power. Keep the base, multiply the exponent. And notice I don't simplify the exponents. I leave it as a base raised to the exponent. That's good enough. And just pay attention. They might say, write without an exponent, then you'd have to simplify. But this is never going to be true. Keep the base, multiply the exponents. So those are your basic rules. Let's take it a little further. Write as a power of 2. Now, if anybody kept their square card, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. That'll get us where we need to go. So 16, rewrite using base, a power of 2, and an exponent. So that a lot of times IB will build from what the first problem into the next. This is 1 over 2 to the 4th, but this is not a power of 2 yet. I need to move the power to the numerator, which means my exponent becomes negative. So all of these problems, you want 2 being raised to some number that represents this value. What did we say earlier? Anything to the 0 power is 1. You can go backwards, 2 to the 0, 1. All right, what is 4? Is 2 squared. I don't like them using x as the times sign, but I get overruled. All right, so I created bases that are the same. So I keep the base, add the exponent. So 2 is already a power of 2. 8 is 2 to the third. So I'm just substituting one side in for a power of 2. I'm dividing bases that are the same, so I subtract the exponents. All right, 13, you have to understand what a prime number is. Your prime numbers are just the number, 1 and the number itself are factors. The smallest prime number is 2. 2, 3, 5, 7. These are all prime numbers. So 9, which one of these can be written as 9? 9 is 3 squared. So I'm going to replace 9 with 3 squared. Now I have a power to a power. So I multiply, and that's it. Prime number as a base. All right, 3 is a prime number, 9, so I'm going to keep the numerator. 9 is 3 squared, and I think that's y. So now I have a power to a power, so I multiply. Now I'm dividing bases that are the same, so I subtract the exponents. 25, I need to replace with a power of 5. 25 is 5 squared, keeping x as my outside exponent. Power to a power, multiply. So if you ever wonder if you finish the question, it says express an exponent form with a prime number base. Prime number, prime number, prime number. Okay. Write without brackets. This is a product, so each value on the inside gets its own exponent. Each base on the inside of my product gets its own exponent. Then I would probably simplify 3 to the third. is 27 x to the third. I would take either of those answers. Here we're dividing a quotient, so each piece on the inside gets its own exponent. And this is just plain simplify, all right? Anything to the 0 power 1. It's not considered simplified with a negative exponent, so the first thing, let me just rewrite this. The first thing I'm going to do is move everything to the bottom. Notice I'm taking the whole thing to the bottom and the exponent becomes positive. What will force it to be on the bottom is if I put a 1 in the numerator. And then the most simplified answer, 3 squared, is 9. So 1/9. All right. Anything to the 0 power is 1 minus 3 to the negative 1 is 1 over 3 to the first. I'm going to move 3 to the negative 1 to the bottom, and it just becomes 3 to the first. 1 minus 1/3 is 2/3. Last but not least, if a fraction has a negative exponent, we got to move the top to the bottom and the bottom to the top. So really the easiest way is to do the reciprocal and make the exponent positive. Then we have a quotient that we're going to simplify. So each base gets the exponent and square each one to get my final answer. And I think that's, oh, no, a couple more. I'm not always good at, you know, when I copied mine, I may have missed that page. So here's a couple extra problems. So if you don't have these on your note sheet, just put them somewhere on your notes. All right, so be really careful about this negative here. Really, it's -3 to the 4th and a squared to the 4th. So take each base to the outside exponent. -3 to the 4th. -3 times -3 times -3 times -3 is positive 81. A negative to an even exponent is positive. Power to a power, multiply. All right. Now, I'm just going to deal with this negative all on its own. A negative to an odd exponent means the whole thing will be negative. Then I'm going to do 2 to the 3rd. And I could have just put the negative with the 2. If that's easier, you're going to get the same thing. A squared to the 3rd, b to the 3rd. So I get -8, a to the 6th, over b to the 3rd. One thing to always double check, when you get done, make sure no bases are the same. No bases are the same. Because anytime if you'd be left with bases that are the same, you can combine them together. Okay. So when we write 4x to the 3rd, doesn't it mean 4 times x to the 3rd? Times, I'm just going to keep it my dot because that's why I like it, 2 times x to the 6th. So all of this is really being multiplied. So I'm going to take 4 times 2 and multiply my numbers together to get my numbers. Now, when I multiply bases that are the same, I keep my base and add the exponents. So you have to deal with your coefficients differently than your exponents, okay? So it's really 4 times 2 is 8. When you're multiplying the bases that have exponents, when you multiply bases that are the same, keep the base the same, add the exponents. All right, same for here. I'm going to rewrite this. So really, I have 15 divided by 3, which is 5, and then I'm dividing bases that are the same, subtract the exponents. So we're trying to condense as much as possible. So real numbers, just combine those together, whether you're multiplying or dividing. Then use your exponent rules. When you're multiplying bases that are the same, keep the base, add the exponent. When you're dividing bases that are the same, keep the base, subtract the exponent. Now there's a whole lot going on in this one. I'm gonna, first of all, I think that's a 6. So I'm multiplying bases that are the same. So I'm gonna add the exponent. Power to a power, I multiply. Here's what I was saying up top. We still have bases that are the same, so I can condense my base. I'm dividing the k's, so I subtract the exponent. So you keep going until you cannot simplify anymore. Oh my goodness, I missed a whole page out of this. Okay. So I'm going to raise each base on the inside to the outside exponent. Now, so 2 to the negative 1 is 1 over 2. Power to a power, we multiply. And c to the negative 3 is c to the third on the bottom. Oh, that's a 4. Oh my goodness. I'm going to start over. The other strategy, I thought that was a 1. The other strategy, if the outside exponent is negative, we could put the whole thing on the bottom and make the exponent positive. That might make it a little bit easier. And then we're going to give each base inside its own exponent. And then 2 to the 4th is 16. Power to a power, multiply. Sorry about that. I couldn't even read. Sometimes they're really light on the screen. Okay, so all final answers, they don't want any negative exponents. So because the a is negative, the whole thing goes to the bottom and becomes positive. The b is positive, so it stays where it's at. The c is negative, so it moves to the top and becomes positive. So negative exponents, you just rearrange. If it's negative on top, it's positive on the bottom. If it's negative on the bottom, it's positive on top. All right, last but not least. So, a couple of things. We can do this a couple of different ways. And I don't remember what the book wants us to do, but what I would probably do is I can raise the whole thing to the top and make the exponent the opposite. So make whatever's in the exponent the opposite. So what that is, if I distribute it, is negative 1 plus n, or n minus 1. So that's writing it without a fraction. Move the whole thing up top, do the opposite of what's in the exponent position, distribute it. And I would say either one of, I'd probably take all 3 of these. I'd imagine the book's looking for this one. It's the most simple algebraically. All right, let's see if I got more. Oh my goodness. Okay, last one. Okay, so anytime you have, if we're dividing by a single x, the easiest way to do this, we're going to put each base over its own denominator. Each piece in the numerator over its own denominator. I can do that when I just have one single part on the bottom. Now I'm dividing x's, So I keep the base, subtract the exponent. X divided by x is 3. There's nothing to combine here, but I need to move it so I have without fractions. When I move the x to the top, it's got a 1 exponent, so it just becomes -1 when we move it to the top. All right. This has a negative exponent, so watch what I'm going to do. I'm going to keep my numerator exactly the same. I'm going to move the x to the -2 to the top, which means my 2 becomes positive. Then I'm going to distribute it back. 2x to the 5th times x squared, multiply base, add the exponents. X squared times x squared, add the exponents. And this is a 1, add the exponents. And finally, that's it. I apologize if you didn't have the right note sheets. I don't think I had them all copied in my book. Hopefully you do. And that's it.